All right, so then I'm minimize that. All right, so both of these lessons had to do with Monster Energy. So they were different. They're not on Statsmatic videos. Those were kind of old data about the iPhone, and they ended with the iPhone 6. So when we're all done with this, we can kind of talk about the takeaway with if you should buy stock in Monster Energy. So you should have this and this in your graphing calculator. They did graph this line for you, but just so you are kind of getting pretty good at that, this is list 1 and that's list 2. So on here, if you were to, you want to stat, calculate, and choose line 8, linear regression. Sometimes I call it the regular formula, linreg, but a plus bx. So when you choose 8, and in my case, this is list 1, this is list 2. To store it, if you haven't done that yet, you have to press the vars over to yvars and then choose y1. Okay, so I'll go through that again. Stat, calc, option 8, list 1, list 2. Somebody just asked me, do you have to delete your list? No, you could have as many lists as you want, and after you run out of numbers, you can name them. So I'll show you how to name the log one. But you want to store the regular equation if you want to see this line. So what you can see here, you can see it better on the video, is the red. So I'm going to hit vars, click right, and you want yvars, and then function is the first one. So you could just hit enter, enter. Okay, so now you should see it there as stored. And then calculate. Okay, so there's all your goodies. Now again, they put this on here for you for this lesson, but we've been doing it, so the more practice you can get, it's awesome. So now when you hit zoom 9, there you have this exact picture. All right. So the first question is, what's the form? So you might have just assumed it was linear because it's moderately strong, linear, positive relationship, but it is not. So if you're unsure, we have to graph the residual plot, which is what this did next. So I'm going to kind of X this off and say it is not linear. It's actually non-linear. Okay, so none of these fit. And you might want to say, like, well, how do you know? And this is how we know when we graph the residual plot. Okay. It's not linear because it has too much of a curve. So it has too much of a curve here that's in there. Now you might say, well, what's the difference? And a backup method to determine if we can use a linear relationship model is to graph the residual plot, which is coming later. Okay, but for now, let's use the regression line to predict the stock price for 2010, then find the residual. So you might have put y hat is equal to all this, but what do we want to write? The predicted value of the average stock price is equal to, then the line, oops, I'm off the grid. So the line is 5608.0958 plus 2.793. Now you could round to like 3 places, that would be fine. But when you input 2010, later on that changes, but you can put in a year. Okay, so the actual is 7.53, I'm sorry, the predicted is 7.538. So now we're going to find the residual. Okay, so I went off the grid here earlier, so I was going to erase it and stick it up there, but I don't think I will. I think I'll just leave it. So this is my work here for number 2. Like I just, So then find the residual. So the residual is the actual minus the predicted, AP. So the actual that happened, I have to look up at 2010, was 3.68. And the predicted is 7.538. So this residual for 2010 is negative 0.3858. All right, so a lot of you guys probably got that on your own. I just heard you guys talking in your groups. All right, so then for 2022, follow the same process. So the predicted stock price is equal to same line, and it's up here too, even if you didn't put it on your graphing calc. Alrighty, and times 2022, and this is 41.0636. Now I'm going to subtract the actual minus the predicted. So this residual is positive. So this is the one for number 3. Maybe I'll box it in red instead. So this is 3. Sorry about when I do things myself, like when I'm not doing them, like this was my practice page. And I'm like, oh, I'll just work off this, just like StatsMedic. Okay, so now, I don't know if you guys all did this. Okay, you were supposed to put in what you just got, so 7.5, here I rounded just for space issues, so I put in 7.54, and we got negative 3.86, so this was number 2, and then this is number 3 down here for 2022. Okay, so then it asks you to graph the residuals. Okay, so this is where we've been. I'm just going to make this a little bit bigger. All right, so the residual plot is another way that you can tell if it's linear. Okay, so this is the long way, and then I'm going to show you the shorter way. But it's worth knowing how to do it, sort of like standard deviation when we did that lesson. So I have this as list 3 and this is list 4. So if you go to stat, and if you want to catch up to me, go ahead and put this is list 3 and this is list 4, now that we just corrected numbers 2 and 3. So the residual plot tells us if it's above the line, then that's the actual being positive. So we got 2 different kinds. I got a positive residual for number 3, and I got a negative one for number 2. Okay. So the reason we have to square residuals is so that they're all positive, because otherwise once we add all those up, it could zero out if it wasn't squared. So you can see either by this chart, well, which points was the actual stock price greater than the predicted. Okay, so greater than predicted was here. These guys, 2006, 8, 20, and 22. And less than predicted are 2010, 2012, 18, 14, 16. All right. So this is called the residual plot. So it's graphing the residuals against the original year. So now we're going to graph this. Okay, and I'll show you where this is. Okay, so the second stat plot, this was the original, list 1, list 2. Okay, so we're going to tweak this. I don't want list 1, I still want list 1, so that's okay. But now my second one is list 4. Is everyone caught up to me? So this is how you call up a list. You hit second, and list 4 is right here, above 4. I mean, not coincidentally, list 1 is above 1, list 2 is against, that kind of stuff. So Then we're going to hit zoom 9. But what's going to happen is my line is still there. So you can take that away. Just go to y equals and you could clear it out. Zoom 9. So that, boys and girls, is a residual plot, and that is what you can sketch right here. Yay! All right, I am going to get green. So this one was positive, positive. This one was negative, negative. I'm literally just sketching it from here. Okay? It doesn't have to be exact as long as it's below. 2016 was pretty close. 2018, 2022. So, yeah?
Did you go over doing the residual plot?
Sure. So when you go back to, we're going to how to do the residual plot. So second stat plot. So if I'm going to do plot 1. So before it was list 1, list 2, but now I'm going to do list 4. So this is the original. This is the original. Then we made a prediction. Then we made a residual list. So I'm graphing the residual. So we're going to just like pretend none of this is here. So now we're just graphing list 1, still the year, and against the residuals. So all right, are you good?
Yeah.
Okay. So then we have zoom 9, and that's what that looks like. All right, so does everybody have that picture? I'll show you the quicker way on the next one. Okay, does this residual plot have a pattern? What does this suggest about the linear model that we used for making predictions? Okay, so this residual plot has a curved pattern. That's no good. So the linear model might not be the best. Okay, so here's our big takeaway. If the residual plot, this is the secondary way to tell if you have a linear model or not, has no pattern, meaning it has random scatter. Boop. I'm going to wipe this out. Gotta get to my whiteout. Then the line is a good model. Boop. Then the line is a good model. So StatsMedic tries to make these fit on one side back to back, which I kind of like, but I also kind of don't like because that's hard for me to do. Okay, I can minimize the calculator now so that you can see all the words. Sorry about that. Okay, so because this residual plot is not random scatter would look like this. Like, here's the residual plot. Like, it'd be a nice, like, random scatter. But if it's got any type of a fan or an exponential look to it, then it's not going to be good. All right. So that is our first takeaway. So let's fill that out. So that's on the back. I'm going to zoom. Okay, so the LSRL, a couple of you were asking me what that stands for. The least squares regression line, and it minimizes the sum of the squared residuals. So this is a good scatter plot. This is a bad one. This is a bad one. A fan is also bad. So what this tells you, if it looks like parabolic, then maybe we have to take the square root. If it looks exponential, then maybe we have to take the log. Okay, so we'll have a teeny bit of algebra. Because you want the residual plot to have random scatter, because that tells you that there's just as many residuals above and below. So the linear model is a good fit. Okay. Okay, so I know that a lot of you guys did this for homework, so I'm just going to flash up to this bottom answer. But before I do that, we did this yesterday in class, okay? You have to be able to read computer printout, okay? So that is the constant coefficient is your A value or your intercept. And then the other one is just the coefficient of x, which is your slope. Alrighty. So that is what you want to get kind of straight. Alright, so I know that you already did this, so I'm just going to be like a cooking show, and I'll make this smaller, and we can talk about this. Okay. This is the same one as the prior year. Alright, so there's a moderately strong positive linear relationship between city and highway fuel economy with no unusual points. So this is a decent line that you have to describe with direction, form, strength, and any unusual features. Always context. Always, always. That's why I got my stamper. All right, between city and highway fuel economy with no, well, that was just context. Now, if you have something close and it says the same thing, that's fine. You don't have to, like, it doesn't have to be verbatim what I have. All right, the equation of the least squares regression line, it's as easy as it is. You're just plug and chug. But make sure you put predicted highway fuel economy. So it's always going to be your response variable, prediction, intercept plus slope. I like this in parentheses. I don't love it when it's times the fuel economy. So the least squares regression line, this line minimizes the sum of all the squared residuals. I put a couple screenshots on Canvas to kind of just bring you up to speed on LSRL. And that indicates, what does that indicate rather about the appropriateness? If it has no clear pattern, it's randomly scattered, then the line is a good model. If it's not a good model, then we have to force it. That's what we're doing next. So you ready? You ready for part 2, which is also, I know what y'all did. Part 2. Yeah. All right. So part 2. All right. So again, I did this one, but I'll try to get through some of it blank so that I can just walk you through. Okay. So let's go back to our calculator, and I'm going to show you the easier way to make a residual plot. Okay, so you have a choice on a calculator. You can, okay, so now stat, edit. I can keep these lists, and I could just scroll and make a new list. So I could call it years, and then I could call it the stock price. But as long as I have 6 lists, I'm going to call this list 5 and this list 6. I don't want you to think you always have to erase it and start over. You could keep piling on. All right. So everyone got their calculator ready? Okay, so stat calc. Now I'm just putting in 6, 8, 10, 12. That's easy enough. 14, 16, 18, 20, 22. Boop. And then I'm going to scroll right, and list 6 is going to be these guys, 2.75, and I'll stop talking because I might be messing you up. Ah, which one did I miss? Dun, 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 dun. If I was on my own calculator, I could hit second insert, but by the time I do that on this one, it'll be longer. All right, so now when I graph this, if we want to get the same picture that they have, where's your calc? All right, let's go. Let's go. Where's yours? Let's go. Oh, killing me. Killing me, Smalls.
Do you have to do anything with the frequency list?
No, not yet. Eventually we do. Oh, it's Max Buck. I should say that in my next vid. Should we see what Max wants in here? Sorry. Hi there. End of class. I said I'm at the end of class. Hey there. Yeah. All right. Sounds good. Oh, little cuties. Let me know he's home. All right. Now, we don't want list 1, list 2. What do we want?
This one is 3, 4.
5 and 6.
5 and 6. Now, if you deleted and said list 1, list 2, then use list 1, list 2. It's whatever your list is, right? So, to call it up, I'm going to use second, list 5, hop down, second, list 6. Same thing, zoom, 9. There it is. Dun, 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 dun.
Wait, Miss Buck,
Yeah.
is there a way to get the line on the red?
Yeah. Oh my gosh, of course there is. The question on the floor is there a way to see the line? How do we see the line? We calculate. You want to start thinking like a calculator. Stat, calc, the line is 8. And now we don't want list 1, list 2,
5 and 6.
5 and 6. But if I erased and mine are list 1, list 2, then, all right, oh boy, abort, clear. Second, list 5, second, list 6. All right, now, who just asked me where to store it? How do we store it? Vars, click right, Y vars, function, calculate. Yay! So again, here's where they wrote that. So they did that for you. I'm just like making sure that you can all do it. All right? Alrighty. So this is that least squares regression. So again, this is going to be your years after 2000 when you put it into the thing. This is going to be your predicted stock price when you put it in. All right. Now, this is, since I'm kind of hopping and I combine these two, you're not too, like, fantastic with R squared yet, but you're going to be there so soon. So what this says is, and here I'm just going to put my own handwriting so I can just kind of talk about it with a pass, is, I'm going to minimize this so that we can see this. Oh, hopefully I'm not making y'all dizzy. All right, 94.3% of the variation in stock price can be explained by the linear relationship with X equals years after 2000. So this is a line that you are going to basically see the rest of the year. So when you're explaining R squared in context, always context. Always, always. Always, always. Okay. Write out, again, I'm kind of forgetting you guys did this for homework, so you probably got this far, because this one is pretty straightforward. The predicted stock price is equal to the negative 20, this is just from above, okay, they gave it to you, 2.7938 times the years after 2000. Now, in the first example, you had to type in the full 2014, but this one, you're just putting in the years after 2000, So when I plug it in for 2014, don't plug in 2014. You're just plugging in 14. All right. So the predicted stock price is $18.52, and that's pretty straightforward stuff that you probably could do. All right, now I'm going to show you how to find the residual plot. Okay, well, the residual itself is negative 5.13. Hopefully you all got that. Remember, residual is actual minus predicted. All right. Ish. Ish is like kind of thing. Okay, now let's find this residual plot. I know it's done for you, but I'm going to show you a quicker way on the calculator. Yeah?
And can you like explain the difference between variability?
Wait, let me finish this, but because I want to get to this. Okay, now this is a quicker way to find the residual plot instead of making a list of the residuals. You ready? Okay, does everyone have the new line? Okay, so you've got, you have to have the line in there. I'm just going to make sure I didn't do anything else. When you calculate this, okay, list 5, list 6, I have to store it. So vars, if you don't store it, it won't give you the residuals. So I'm just doing it again. Okay, now that's where I got that 94.3%, by the way. So let's go to second stat plot. I want to graph the residual plot. Easier, instead of making a whole list again. So choose that one. Now I want list 5, but now what do I want my Y list to be? Say the residuals. Yes. So I don't have a list of residuals, but it's here. You just don't know it's here. So it is, list is above stat. So second list. Dun, 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 dun. Oh. So choose 7. Now you can graph it. Zoom 9. Uh-oh, got to get rid of my line though. Clear. Zoom 9. So that is this. Oh. That's this.
Is this 6 points?
All right. So let me just half and half this. Look at that. That's a really good vid. So this does not have a nice random scatter. The original data is not linear. Is it exponential? Perhaps. So that, my boys and girls, is where we're going to go on Monday. There's my chicken scratch copy. So if you didn't do it this time around, do it tonight. Do it tonight.